remember, when two functions are inverses of each other, we always get x as our answer. That's because they reflect over the line y equals x. So number 1 wants me to show that f of x equals 2x cubed minus 1 and cube root of x plus 1 divided by 2 are inverses graphically. So what I can do is if I go to my y equals on my calculator, that is the top left button. Then I want to type in my two equations. I have 2. X is the button next to alpha. The exponent button is right above divide. And then I type the 3. I arrow over to the right to get out. Is it really? Okay. Then I arrow to the right to get out of my exponent. And then, wow, it's really slow. Then I want to do minus 1. That's what's on the paper. I don't know why it's not on the screen. Yeah. And then for y2, I want to do the cube root one, which I'm really disappointed it's lagging on. To get the cube root, you want to press math. And then choice 4. No, that one's probably broken. Really? Okay. So then I want to choose 4. And then type this in. I'm going to type it in parentheses for my numerator. So I'm going to do x plus 1 in parentheses and then divided by 2. And then we'll wait for it to show up on the projector. That is really, really bad. Okay, so has everyone typed these in? Okay. Then I want to go to my graph. Okay, so here's what my two graphs look like. Yeah. Do you think these two are inverses? No? Okay, so if I go back and I add a third one, y equals x, and then we'll wait for my projector. I am, it's so slow today. Okay, so now that this line has finally appeared on the projector, are those two lines reflecting across each other? Y equals x for the third line. So, yes. So I am... Yeah. Okay. So if you stop talking, I can answer all your questions. Remember, inverses are always reflecting over y equals x. This is why when we were solving Tuesday, I always wanted you to plug it into each other to make sure that you were getting y equals x. Because that was proving that they reflect over each other. The y equals x is up here at the top of your notes. Okay? So I went ahead and graphed that in addition to the two other graphs I had. Oh, my red pen is... So then what I'm going to do for my final answer here is, it just wanted me to show that. So I'm going to draw that y equals x as a dashed line to show that they're reflecting over it. You'll see when it comes up on the projector. To not have to wait for the projector. So does that make more sense, Iris? Okay, so I'm gonna say 3 minutes, and then I'm gonna try and restart the projector to see if it works. Huh? Okay, so the next thing we're going to talk about is being one-to-one. Functions that have inverses are one-to-one. This means they're obviously a function, so they pass the vertical line test. And then they also have to pass the horizontal line test. That checks to make sure there's only one output for every input, because when I find the inverse, I flip the inputs and the outputs, and I want to make sure that the inverse is also a function. So number 3 wants me to see if the function of f of x equals the square root of x plus 1 is one-to-one. What I want to do is I want to go ahead and graph this. So I want to clear out all of my equations from my calculator. And then I want to type this in. The square root is, if I press the second button and then diagonal from 7, it's got it in, I think it's also blue for you, a square root above the x squared button. You press that, you type x, arrow over, and then do plus 1. And so then I want to graph this. Yeah, I had to restart the whole computer and the projector. Whoa. That's a lot of pins. I got them at Costco. It's the ones like these. Okay. 10? $10? I think so. Okay. Okay. So I want to do my horizontal line test. So if I have something that's horizontal and I drag it through, I want to check to make sure it's only touching once, which it is. So, is this one-to-one? Yeah. And then I'm going to sketch a picture of this on my paper so I remember what it looked like. Questions here. So on number 4, I graphed this on Desmos so you can kind of see it a little bit better. Horizontal line test is just checking to see if there is one output for every input. So if I put in like a y value of y equals 2 to get a horizontal line on there, it's only touching this once on the graph. So if I change this like to different y values, it's only touching my red graph once. So this one is one-to-one. Okay. Oh. Yeah. Okay. So, I'm still teaching. Tara, I'm teaching. So, this is kind of what we were doing yesterday. 5 and 6 want me to find the inverse functions. I've formally written out the steps to finding an inverse function. So the first thing you want to do is replace your f of x with y. Guys, stop talking or I'll give you a seating chart tomorrow. You only need to be quiet for like 3 more minutes. Okay, so then what I want to do is, now that I've replaced f of x with y, I want to switch the x and y values. So then it's going to become x equals 5 minus 3y divided by 2. Okay, and I want to solve for y. So what's my first step to getting y alone here? What? Oh yeah, multiply by 2. I thought you said divide. Okay, so I want to multiply both sides by 2, which will give me 2x on my left. What do I get on my right? 5 minus 3y. And then, what do I want to do next to get y alone? So then I have 2x minus 5 equals 3y. Divide both sides by 3. Oh, yeah, it's negative 3. My bad. Okay. Then what do I get when I divide by negative 3? Can I simplify that? So then I just get y equals 2x minus 5 divided by negative 3. Okay, that's right. Then the final step is, because I am asked to find an inverse function, I want to replace my y with f inverse of x. So then I'm just going to have f inverse of x equals 2x minus 5 divided by negative 3. Okay. So questions on 5a. Okay. So same thing for b. I want to start off and replace that f with a y. Okay, then I want to switch my x and y, so it's going to become x equals the square root of 2y minus 3. Okay. Then how do I start off by getting y alone? Close, it's a square root. Square it. So I want to square both sides. That's going to give me x squared on the left and just 2y minus 3 on the right. So then I want to add 3 to both sides. Okay, then what do I want to do? Okay, so that gets me Thank you. And then my final step is to replace that y with f inverse. Okay. Questions here?